A free body diagram is an illustration that shows the forces that are acting on an object, and that is something that we're going to talk about in this episode of Physics is Easy with Mr. Jesse. Being able to draw the free body diagram of an object is a very essential skill, especially when we are dealing with problems that involve the Newton's second law of motion. So consider this illustration. We have here M1, and this M1 is connected to a string, then to a pulley that is then connected to M2, and this M2 is on an inclined plane. Say for example, this inclined plane is rough and therefore friction is present. So let us identify, or let us draw the free body diagram of M1 and M2. For M1, the forces that are acting on it are the following. So we will always have the force of gravity going down. So we would call this W1, which is the weight of mass 1. And since it's connected to a string, then there will always be tension along the string, and that is directed upward. So we have tension right there. These are the only forces that are acting on M1, and since the acceleration is directed upward, then we could actually assume that, or we could actually say that T1, or the tension, is much greater than the weight of mass 1. But that's no longer part of the free body diagram, although you could show that by drawing the tension a little much longer compared to that of the weight of the object. So let me decrease its length. Alright, that way we would be able to see that indeed with these forces, that T is much greater than W1, the object is going to accelerate upward. Now, before we draw the free body diagram of M2, let us first identify the forces that are acting on M2. So number one, we will have the force of gravity, or the weight of M2. Second, again, this is the force of gravity. We also have the normal force, since the object is in the inclined plane. So if an object is in contact with any surface, there will always be a normal force. Right. Second, since M2 is connected to a string, then there will also be tension. And as I have mentioned earlier, the surface of the inclined plane is rough, so therefore M2 would also be acted upon by friction. And in this case, it should be kinetic, because we could see that there is acceleration as pointed out by this arrow right here. So there is acceleration. So if there's friction, that kind of friction would be kinetic. If there was no, if there's acceleration, the kind of friction that is present is kinetic. If the acceleration is zero, it would be static, which is something that we're going to talk about in the next video. So let us now draw these forces that are acting on M2. So the first one is the weight. Now the weight of an object would always be directed downward. So you just have to draw an arrow straight down, and that would be the weight, or that would symbolize the weight of the object. So we have that. Let's call it W2. Next, we have the normal force. Now the normal force is always perpendicular to the surface that the object is in contact with. So another term for normal is perpendicular. So once again, it's perpendicular to the surface that the object is in contact with, and it points away from the surface. So to do that, our normal force, since this is our surface right here, so we just have to draw a line that is perpendicular to the surface, and it should be pointing away from this surface. So to do that, we will have something that looks like this. That is going to be our normal force. It's perpendicular to the surface, and it points away from it. So that's our normal force. Now the next force is tension. So tension would always be drawn along the rope. So we could actually draw it like this. It should be drawn along the rope. Okay, so that is our tension, we'll label it with T. And this tension, the tension that we have here on the ball, the tension that is acting on the ball is actually equal to the tension that is acting on the block. Please take note of this very essential information. Since the two objects are connected by the same string, so they will be experiencing the same tension. So we have number 3. And lastly, kinetic friction. So friction is always directed opposite to the motion of the object, and since it is said here that the acceleration is directed downward, so therefore the acceleration would be directed upward. It's opposite to the motion of the object. Alright, so it would be drawn this way. This would be our friction, and I'm gonna call that FK, which stands for kinetic friction. And that is the free body diagram of M2. However, I would like to direct your attention to the weight here. Now this weight, alright, this weight is in fact composed of two parts. We have the y component of the weight and the x component of the weight. So let me draw that. So the y component of the weight would be something that is in the same direction as the normal force. Let me draw that in blue. So again, the weight is in the same, or rather in the opposite direction as the normal force. So that is the y component of the weight, which I'm gonna call wy. And it also has an x component, and the x component of the weight would be opposite to the direction of the kinetic friction. So it would be along the direction of the acceleration. So the acceleration is directed downward, so the x component of the weight would also be directed in that direction. So it would be drawn like this. So this is my x component. Let me draw it properly. That my x component is going to look like this way. Alright, and I'm gonna call that wx. Now you have to remember that this wx is the one that is responsible for the object's motion. So I'm gonna write that down, responsible for the object's motion along the inclined plane. The inclined plane. So it is for that reason that the object would slide down. It is because of the x component. It's because of the x component of this weight right here. Also, you have to remember that this y component of the weight is equal in magnitude to the normal force. Let me write that down. That the y component of the weight is equal to the normal force. And it is for that reason that the object remains in contact with the inclined plane. Although the y component of the weight is pointing downward, the normal component is pointing upward, but in terms of magnitude, rather the normal force is directed upward, but in terms of magnitude, they are actually the same. And if we are going to compute for this, that is just equal to the mass of the object that is on the inclined plane multiplied by acceleration due to gravity cosine of the angle theta, and that theta right there is this theta. Also, you have to remember that the x component of the weight is equal to mg sine of the angle of inclination theta. Now, how is it gonna be sine and cosine is something that we will be discussing in the next video. But for now, you have to take note of the following formula. Normal force is mg cosine theta, and the x component of the weight is mg sine theta. These information is very important, especially in dealing problems that involve the applications of Newton's second law of motion. And that concludes this lesson. Always remember, physics is easy with Mr. Jesse.